In this video, you will learn how to configure a route-based VPN on a Forcepoint Next Generation Firewall. A virtual private network, or VPN, is used to connect secured private network over public networks, by encrypting the connections going through VPN. With a VPN, user traffic can be transported over unsecured links without compromising the data confidentiality. You can establish a VPN tunnel between a VPN client and a VPN gateway to secure user traffic to the corporate resources. This is called a mobile VPN. A tunnel can also be established between two VPN gateway devices to secure all the traffic between two locations, such as the corporate head office and the data center. This is called a site-to-site VPN. Forcepoint Next Generation Firewall provides three types of site-to-site VPNs. Policy-based VPN, where the traffic is sent to a tunnel based on an access rule match. Route-based VPN, where traffic that is routed to a tunnel interface is sent to a tunnel. VPN broker, where VPN gateways are joined to a broker domain. The VPN broker dynamically instructs the gateways to establish the tunnels when there is user traffic between the two gateways. In this video, we will focus on the steps to configure a route-based VPN between two Forcepoint Next Generation Firewalls. These are the main steps to create a route-based VPN between two Next Generation Firewall engines. First, you need to add a tunnel interface for each Next Generation Firewall engine. Then you add the routes to the peer gateway protected networks via the tunnel interface. Optionally, you can create a custom VPN profile if the predefined profiles will not meet your needs. Next, you need to create a route-based VPN tunnel element. Then, access rules must be added to allow the traffic between the protected networks. After all the configurations are complete, you will need to install the policy and verify the tunnel is working. A tunnel interface is used to route traffic through the route-based VPN. Thus, the first configuration step is to add the tunnel interface for each Next Generation Firewall engine. To do this, open the firewall for editing, switch to the interface's configuration, and click Add Tunnel Interface. Then click OK to save the tunnel interface. Add the tunnel interface for the second Next Generation Firewall engine that will be included in the route-based VPN. Optionally, you can also add an IP address for the tunnel interface. This IP can be used, for example, to negotiate a dynamic routing protocol neighborhood through the tunnel. Because static routing is used, you will add routes via the tunnel interfaces to the peer gateway protected networks. This is done on the routing configuration page. Right-click the tunnel interface that was just added, select Add Network, find the remote gateway network from the list, click Add, and then OK. To verify that the network was added, expand the tunnel interface. Be sure to click the Save button to save your changes. You can add routing on the other firewall routing configuration by following these same steps. An optional step is to create a VPN profile. This could be needed, for example, when a VPN tunnel will be established with a third-party gateway, and none of the built-in profiles meet the requirements that the third-party gateway administrator has provided. To create a VPN profile, click the Configuration button, expand to SD-WAN, expand Other Elements, Profiles, and click VPN Profile. Then click the New button, and VPN Profile. Give a name for the profile, and define the settings as needed on the ICE Security Association and the IPsec Security Association tabs. These settings include cipher algorithms, message digests, among others. On the Certificate Authorities tab, you can define which VPN certificate authorities will be trusted as the signers of the gateway certificates, if certificate authentication is used. Once the settings are defined, click OK to save the VPN profile. In this setup you will use one of the predefined VPN profiles. When the AESGCM cipher is used for the IPsec Security Association, it will allow the Next Generation Firewall engines to use the hardware acceleration for the VPN encryption and decryption, which gives best performance. The next step is to create the route-based VPN tunnel element. Under the SD-WAN section, click Route-based VPN tunnels, and then the New button. Select Route-based VPN tunnel. Optionally give a name for the tunnel. The tunnel type options are GRE, IP/IP, SIT, and VPN. You will use the VPN default option because that will create an IPsec tunnel between the gateways. On the VPN profile selection, you will select the profile called SuiteBGCM256, which means that the recommended cipher will be used. In the local box, click the Select button and select the Next Generation Firewall gateway. Since you are creating a tunnel between two Next Generation Firewalls, it does not matter which gateway you choose as local or as remote. Once both gateways are selected, the tunnel details get populated under the gateway definitions. If either of the gateways has more than one tunnel interface, you will need to select the correct one. In other words, this is the tunnel interface with the route to the peer gateway protected networks. This links the tunnel interfaces so that the traffic will be sent to the correct peer gateway. Click OK to save the route-based VPN tunnel. In order to allow traffic to go through a route-based VPN tunnel, the policy of each firewall must allow it. You will now add the rules to allow the traffic. Click NGFW engines under the NGFW section to add the rules to NGFW1, and then right-click the firewall and select Current Policy, Edit. On the policy you need to find a suitable position for the new rules. Then right-click and select Add Rule after. You will add the first rule for connections opened in one direction. Because you want to allow all traffic, you will set service to any. Since the traffic will be using the route-based VPN tunnel, the action will be allow and the VPN action does not need to be defined. After the first rule is added, you will add the second rule below for the connections opened in the opposite direction. The same rules can be used on the NGFW2 policy as well. Thus, you will select both rules in the NGFW1 policy by holding the Control key and selecting the two rules. Then right-click and select Copy Rule. Next, you will open the NGFW2 policy for editing. Find a suitable spot for the rules, right-click and select Paste. To save the policy, click the Save button. At this point, changes have been saved in the SMC, so you will need to install the policy to both firewalls. As you have the policies open, you can press the Save and Install button on each policy to start the policy installations. Now you just need to wait for the policies to get installed before testing that the tunnel works. To verify the connectivity, you will connect to a host at one of the LAN networks to generate some traffic. Because both firewalls were configured to allow all traffic between these networks, you can use ping and see that replies are received. Finally, in the SMC you can check that proper security associations were established by right-clicking, for example, NGFW1 and selecting Monitoring, VPN Security Associations. In the Security Association list you can then see that IPsec Security Association is established between NGFW1 and NGFW2, where any network is used as the traffic selector for both gateways. With the route-based VPN tunnels, this is expected because any network is used as the traffic selector for both gateways.